Welcome back to episode 2 in Understanding Monopoly. So now we'll be looking at how monopolies maximize profit. So for comparison, we'll look at some review of how firms that are in perfectly competitive markets maximize profit. Remember, back in that condition, the firm was a price taker. They cannot influence the price. So here it was market demand in a perfectly competitive industry, so it's downward sloping, following the law of demand. We buy less when something gets more expensive. Now, if you're just one tiny firm in that giant market, if you change your production from 0 to 8, that's not going to matter a whole lot when there's another 30,000, 40,000, 50,000 units out there. So when you sell more units, it does not influence the market price. That's why you're a price taker. You have to take the market price as given and just work with that. As a consequence, for the perfectly competitive firm, price was equal to marginal revenue. So if you sell one more unit, price does not change, so the price is just how much extra money you get when you expand your production. Now it's going to be different when you look at monopolies. So let's talk about monopolies now. Monopolies have market power. Your book calls them price makers, though I think that's a less common term. You'll probably hear market power more often. So what that means is that monopolies can influence the market price. So there's only one firm, and they start expanding their production here, that's going to involve lowering price. So now what's going to happen is that price will be price will be greater than marginal revenue. So here's an illustration. Let's say a firm is selling right now 100 units and they're selling them at a price of $10 per unit. 10 times 100 is 1,000, so total revenue is going to be $1,000. Now let's imagine the firm wants to sell one additional unit. So they're trying to expand their sales to 101. In order to make that happen, they had to lower the price. Let's say you got to lower price to $9 to sell your 101st unit. Let's calculate total revenue there. 9 times 101 comes out to 909. So instead of total revenue being 1,000, now total revenue has gone down to 909. That's a decrease of $91. So while a price is 9, the marginal revenue, the change in revenue, is negative 91. So price and marginal revenue are no longer the same thing. In particular, price is going to be bigger than marginal revenue. So back earlier, we talked about perfect competition. Raising quantity always raised revenue because price was unaffected. That's no longer true. Now if you increase production, the effect on revenue is going to be ambiguous. So revenue, we know, is still price times quantity. If you increase Q, that by itself is going to raise revenue. However, in order to raise Q, you had to cut P. Cutting P by itself reduces revenue. So now the effect on total revenue is going to be ambiguous. We don't know just from the surface which of these two effects is stronger. You got to do some math to find out the effect on total revenue. So because we've broken the link between price and marginal revenue, that old profit maximizing rule we had in the earlier chapter doesn't work anymore. So for perfect competition, the rule was price equals marginal cost, but that relied upon price being the same as marginal revenue. Once you've broken that link, you can't use that rule anymore. So here's what we're going to do instead. So there's a name for the two particular effects we saw that made the impact on revenue ambiguous from an increase in Q. All else equal, a boost in Q is going to boost revenue. Sell more stuff, you get more money. We call that the output effect. The trade-off, though, is that to get people to buy that extra output, you had to reduce prices on all of your production. Reducing prices, all else equal, is going to reduce revenue. We call that the price effect. So while a particular rule of price equals marginal cost does not apply anymore, we can go back to the more general condition we had earlier. So the general rule we established was that marginal revenue equals marginal cost. In the special case of perfect competition, price equaled marginal revenue, so you make that substitution, which produced price equals marginal cost. We can't do it anymore. We just got to revert to marginal revenue equals marginal cost. So here is a numerical example. I've given you price and quantity for a monopolist. I've also told you what the total costs are. TC is total costs. So here's your job. Calculate all the blanks here. Find total revenue, find marginal revenue, find marginal cost. Once you've done all that, find the profit maximizing price and quantity. With that information, you can then find what is the firm's profit. So normally in class, I'd pause here for a few minutes, but this is a video, not a live in-person class. So what I'll do instead is I'll tell you, just pause the video for as long as it takes you to figure out that problem. So when you've solved it, come back and continue, and we'll go over the answer. So presumably by now you have figured out the problem. So let's go over the answer. Revenue is price times quantity. To fill in this column here, I just multiplied these two guys together. 5 times 1 is 5. 4 times 2 is 8. 3 times 3 is 9. And 2 times 4 is 8. So that's our total revenue column. Now let's go find marginal revenue and marginal cost. So we know that marginal revenue is the change in total revenue when you produce one additional unit. Similarly, marginal cost is change in total cost when you produce one more unit. So here's the pattern. When we produced one unit, our total revenue was 5. We had a second unit, total revenue rose to 8. That's an increase of 3. 5 plus 3 is 8, so we know marginal revenue must be 3. In like manner, 8 plus 1 is 9, so that tells us marginal revenue is going to be 1 over here. 9 minus 1 is 8, so MR is going to be negative 1 in this part of the table. Costs follow the same pattern. 6 plus 1 is 7. 7 plus 1 is 8, and 8 plus 2 is 10. So that completes our table. Now we still have a little bit extra work to do. We also want to find what is the profit maximizing price and quantity. To do that, we got to look at our profit maximizing rule, which we said for a monopolist was marginal revenue equals marginal cost. So where does that happen? Well, it's not here. Here, marginal revenue is going to be bigger than marginal cost, so that can't be right. This one's equal, so it must be price of 3 and quantity of 3. Our last row of our table does not work. Here, marginal revenue is not equal to marginal cost, so price of 2, quantity of 4 is not the best choice. So now focus on this row because that's where MR equals MC. To find the firm's total profit, you just subtract total costs, 8, from total revenue, 9. That leaves the firm a profit of $1. So that's how you figure out that example. So the same kinds of patterns will work for many, many other types of problems. Now, if you're following along your textbook, the tables there might look a bit different, but the ideas are the same. So what your book is doing is they insert marginal revenue and marginal cost in between the rows with price and quantity. So here, with the same numbers, it looked like this. We still have 5 plus 3 is 8, but now that 3 goes in its own row. and likewise 6 plus 1 is 7, but that 1 has its own row to itself. Likewise down here, 8 plus 1 is 9, 7 plus 1 is 8, 8 plus 2 is 10, etc., etc. So that's what your book is doing. Now, why did I pick a different format in the earlier slides like we had back here? Well, that's because some of your smart work is going to look like this format here, and most of our books are also in this format, so I use this one for demonstration purposes. So you want to be comfortable with this format because you'll see that elsewhere in some of your assignments. Now, moving on, I have some extra practice for you guys. We're also going to calculate the price elasticity of demand for this numerical example. There's a purpose to this, so we learned about this way back in chapter 4, and we saw some implications for what that meant about revenue, and also what that meant for a price maker, or for a firm with market power. So go ahead and go back to your notes in chapter 4 if you need to, and calculate what the elasticity is, and pause the video. When you come back, we'll find what the elasticity is. So presumably by now you have solved the problem and you're now continuing to see the answer. So remember, we look at the change in Q between 2 points on the demand curve. Here Q has risen from 1 to 2, so that's going to be 1. We use the midpoint method to find average quantity. I emphasized back in chapter 4, we don't average all 4 of these guys. We're just averaging the 2 quantities for those 2 points on a demand curve. So we're just averaging these 2 points. Average of 1 and 2 is going to be 1.5. We do the same for price. Here price has fallen from 5 to 4. It's a change of -1. Likewise for average price, you don't average all 4 of these guys. You just average 2 of them. Average of 5 and 4 is going to be 4.5. That's where that number came from. Likewise down here, we're going to average these 2 points together. So change in Q is 1. Q rose from 2 to 3. The average of 2 and 3 is 2.5. Price has fallen from 4 to 3. It's a change of -1. The average of just these 2 points is 3.5. Very last pair. Quantity rises by 1 again, so we put a 1 in that column, in that cell. The average of these 2 points is 3.5. Price has fallen by 1, so it's going to be -1 there. Average of 3 and 2 is 2.5. So you've got all the ingredients in place to find the elasticity. So now let's go through the final step and find what is the price elasticity of demand. So remember in chapter 4, you had this formula. It was percent change in Q divided by percent change in P. That is telling us how responsive, how sensitive is quantity to price. If you raise prices, we know consumers will buy less. Do they buy a lot less, or do they buy just a little bit less? That's what this number is going to tell us. So we find out by looking at the change in Q divided by average Q. We divide all that by change in P over average P. So for our first pair here, change in Q over average Q is going to be 1 over 1.5. Change in P over average P is going to be -1 over 4.5. Put it all together, you get an elasticity of -3. Recall from chapter 4 that the price elasticity of demand should always be negative. That's because you'll buy less when something gets more expensive. Law of demand. For the next one, we have change in Q over average Q being 1 over 2.5. Change in P over average P is going to be -1 over 3.5. Put all that together, and what you're going to get is -1.4. For the very last one, we take 1 over 3.5 and we divide that by -1 over 2.5. That works out to -5 over 7. So why did I drag you guys through this exercise to find elasticity, which was way back in chapter 4 many weeks ago? Well, there's an important lesson we had back in chapter 4 that's applicable to monopolies. So we said in chapter 4 that a firm has market power, and monopolists do have market power, the ability to set prices. They will never set a price where demand is inelastic. So we have this picture in your textbook showing what happens if you reduce prices when demand is inelastic. So on one hand, slashing prices helps you because it helps you sell more units, and selling more units is going to boost your revenue. On the other hand, cutting prices is going to mean less revenue per unit that can reduce your overall revenue. So which part of trade-off is going to dominate? Well, when demand is inelastic, then cutting prices leads to only a small increase in quantity. So here, your revenue per unit has been cut in half, but the number of units you sell has only increased by a third. That's going to drag revenue down. You're going to lose $2 if you cut prices here. So overall, it's just a bad idea. Slashing prices reduced your revenue, and also it increased your costs. Producing 4 units instead of 3 units is going to cost you more money. So less revenue plus more costs is going to boil down to less profit. So if you have any ability at all to set prices, you do not want to be in that inelastic region. So you go back to our numerical example, you can verify that this is true. So in our problem we had before, we established that this is the profit maximizing combination, price of 3, quantity of 3, and the elasticity there was less than -1. It was minus 1.4. Remember, the elastic region is where the elasticity is less than -1. It's more negative than -1. That means that quantity is going to respond more than 1 for 1 to a change in price. The elastic region is one down here where the elasticity is between 0 and 1. That means that the response to quantity is going to be much smaller to a change in price. We call it inelastic. So that ties together what we learned about monopolies, what we learned earlier about elasticity. So they are connected. It's not just some random topics here. You can also look at the monopolist profit maximization problem graphically. So here you have a number of curves. Our green line is the demand curve. We also have the marginal cost curve. And we have ATC. Remember, ATC is average total cost. Now, we could show, if I could use calculus, that if you have a linear demand curve, like this one here, then your marginal revenue curve has the same intercept, but it's going to have double the slope. If you're curious about that proof, go ahead and take intermediate micro. They'll probably show it to you there. So we know that the profit maximizing rule for the monopolist is marginal revenue equals marginal cost. So look, where does that marginal revenue curve intersect with the marginal cost curve? That happens right here. That's step one. That's going to pin down our profit maximizing quantity. That appears to be about 8 for this firm. So we're not done. That's only step one. We also got to know, what is the profit maximizing price? Remember, a monopolist, unlike a perfectly competitive firm, sets both price and quantity, not just Q. So let's see how to do that. Once you pin down Q, you got to go plot that quantity on the demand curve. So here's demand. That happens right around here. Then just go over to your y-axis here, and that's going to tell you what the price is. That appears to be around, looks like 65-ish. So the firm should charge a price of $65 per unit and sell about 8 units. With that all in place, you can now calculate graphically the firm's profit. So it's shown here as this shaded rectangle. The width of the rectangle is the number of units the firm has sold, so about 8. The height of the rectangle is given by the gap between price over here and average total cost, this point down here. So the price is the revenue you're getting per unit on average. Average total cost is the cost per unit on average. The distance between the two is going to be profit per unit. So this rectangle is giving us profit per unit, the height, multiplied by number of units, the width. So this shaded area represents total profit. So that's how much money this firm is making. That wraps up part 2 on how monopolies maximize profit. Come join us again for episode 3, which we'll learn about what are the problems with monopolies. Why do you think monopolies are usually a bad thing? So we'll stop here for now.